So now we are on example 5, critical region method for testing mu. Now consider the example regarding sunspots. Okay, let x be a random variable representing the number of sunspots observed in a 4-week period. A random sample of 40 such periods from Spanish colonial times gave us the number of sunspots per period. All right. Now, this data was given in example 3. All right. The fact is, we saw in that particular example that x bar is approximately, that is the sample mean, is approximately 47 and sigma is known to be 35. All right. I mean, we are using the previous studies. All right. Now, it is thought that for thousands of years, the mean number of sunspots per 4-week period was about 41. Mu is 41. Do the data indicate the mean sunspot activity during the Spanish colonial period was higher than 41? Use alpha equals 0.05. So this is essentially it is the third problem all over again. You now are going to use a different method, critical region method. Okay, here is your null hypothesis and here is your alternate hypothesis. Okay, with that our sigma is known, so we are going to find the standardized value x bar minus mu over sigma over square root m. Z comes to be approximately 1.08. Now notice what we do. Alpha is given to be 0.01. So you want to determine the critical region. The critical region for 0.05 alpha is 1.645. Let's look it up. 0.05. Okay. Now this is the right test. So you're on the right hand side. So it is 0.05. For the right tail test is positive 1.645. All right. Critical value is 1.645. All right. So we want to conclude the test. Now look at that. Our sample test statistic says 1.08. All right. So that is the critical region for which we got the critical value to be 1.645. Whereas our sample statistic is here. It's not in the critical region. It is here. Sample test statistic does not fall in the critical region. So we fail to reject H0. If it had fallen, you would have rejected. But here we don't, so you cannot reject. We fail to reject. Interpretation. Interpret the results, right? At the 5% level of significance, sample evidence is insufficient to justify rejecting H0. It seems that the average sunspot activity was the same as the historical average. How do the results of the critical region method compare to the results of the p-value method? Well, how are these two methods to be compared? Results are the same. In both cases, we fail to reject H0. So here is a summary of the procedure. Compute sample test statistic using an appropriate sampling distribution. Using the same sampling distribution, find the critical values, be it right-tailed, left-tailed, or two-tailed. For a right-tailed test, if my sample statistic is greater equals the critical value, that it falls in the region, reject H0. If the sample test is outside the critical value, if it falls outside the region, critical region, you cannot, so you fail to reject H0. Now this is for a right tail test. For a left tail test, if the sample statistic is to the left, so somewhere is critical value, If you fall to the left, then you are in the critical region. So reject H naught. If you are not in the critical region, fail to reject. So it's basically whether you are in the critical region or not. All right. Two-tailed sample test statistic either lies at or beyond critical values, reject, or between critical values, fail to reject. Okay. So this completes our theory. We'll look at more examples ourselves to have a better understanding. Okay. Until then.